Hello, we're going to be learning about positive, negative, and no correlation data statistics today. The first kind of correlation we are going to talk about today is a positive correlation. And all this means is that the dots are in this is called a scatter plot because they're all scattered around. They're not making an exact picture. The correlation just means that they're trying to make a picture, that they're trying to be a line or some other shape. In this case, they look like they're trying to be linear, maybe like you guys standing in line ready to go to lunch. They're all kind of scattered about. We have strong and we have positive correlations. The stronger the correlation, the closer it is to making a line. The weaker the correlation, it still looks like it's making a line, but it's a little bit more spaced out. So in this one, these are pretty close to making a line here. So we're going to say that this one has a strong, positive correlation. Over here, these are a little bit more spread out. They're still kind of in a line-esque, but they're not as tight and close together as the first one. So we're going to consider this one a weak positive correlation. Another word for correlation you might hear is trend. You've heard of things trending a lot. A lot of times it can also mean that they're trending in a positive way or a negative way, which relates to slope of a line. Last thing I want to point out is sometimes points are really close together, kind of like right here. They're kind of like a little tiny group of their own, kind of like you're standing in line with your friends talking to them and everybody else is talking to their friends or they're spaced out. This is called a cluster. And then this guy way out here, he doesn't really fit in the line. These are more of a line than this one is. That is called a outlier. The next correlation is a negative correlation. And again, instead of the word correlation, sometimes we see the word trend pop up. Just like the positive correlation, we have weak correlations and we have strong correlations. And just like in slopes, our negative we know is going to slant downward. That's what a negative slope looks like. So if we're going to look at these points and say they're trying to make a line, it looks like they're sloped in the negative direction, so that's why it's a negative correlation. These are a little bit more spaced out, so we're going to say that this one is the weak correlation or weak trend. And over here, they're a lot tighter together. You can definitely see they're more of a line. We just need to move a couple of them in and they would be a line. So this is considered to be a strong correlation. Just like in the positive correlation, we have a little cluster here. But I'm not really seeing any outliers, nothing that stands out from the rest of the group. The last correlation is a no correlation. And as you can see, the points are kind of everywhere. It's really scattered about. No one's really in a line whatsoever, trying to even make a line. This would be kind of like you guys at recess, just kind of all over the parking lot and doing your own thing. So when we see one like this, we can't say it's positive, we can't say it's negative, it's definitely not strong. So all we say is it has a no correlation. Or again, the other word is trend. Now let's look at some examples, word problems to where they would be positive, negative, or no correlation. Let's think back to what we know about slope. We know that if the slope of the line is positive, we can have a positive over a positive, or we can have a negative over a negative, and they both are going to equal a positive. In the negatives, we know if we have a negative over a positive, that equals a negative. And if we have a positive over a negative, we also get a negative. That also goes back to 7th grade integer rules. And no correlation, we're not going to see any kind of positive or negative relationship between them. So looking at the problems, pick out the two things that are being compared. In the first one, it's talking about the speed you drive and the time it takes to reach your destination. So the two things being compared are the speed you drive and the time it takes to reach your destination. So if your speed is increasing, will it take you more or less time to reach your destination? If your speed is increasing, it should take you less time to get to your destination. If I'm going 50 miles an hour and you're going 40 miles an hour, my speed's faster, it'll take me less time to get to where we're going. So this is a negative correlation. Your shoe size, there's the first thing we're comparing, and the colors in a rainbow. Your shoe size does not have anything to do with what the colors in the rainbow are, and vice versa. So this one has no correlation. And the last one, the number of months and the amount in your savings account. So we're going to compare the number of months that are happening to the amount in your savings account. So as the number of months increase, like month 1, month 2, month 3, so your months are increasing, what should be happening to your savings account? Again, your savings account is something where you want to save money, not take any money out. So what should be happening is that your savings account is growing and it's increasing as well. Therefore, this would be considered to have a positive correlation. Let's look at the next 3 and see if we can determine if they're positive, negative, or no correlation. The number of books read is the first thing we're comparing, and the day of the week. If I read 5 books on Monday, does that mean I'm going to read more on Tuesday or less on Tuesday? If I read 7 books on Wednesday, does that mean I read more or less books on Sunday? These really don't have any kind of relationship with each other. So we're going to say that this one has a no correlation. Number 5, time running on a treadmill and the number of calories burned. Well, the more time, as my time increases on the treadmill, what should happen to the calories I'm burning? They should increase as well. And vice versa. The less calories I burn, or the less time I run on a treadmill, the less calories I should burn. So there should be a positive correlation with this one. And number 6, the temperature on a warm day and the amount of snow on the ground. Well, the temperature on a warm day, it's a warm day and the temperature is probably going to increase throughout the day. So as the temperature increases, what's going to happen to the amount of snow on the ground? Well, it should be decreasing because it will be melting. Therefore, this has a negative correlation or trend. Okay, let's look at these last 3 and determine if they're positive, negative, or no correlation. The number of people who go to the movies and the ticket sales are the 2 things that are being compared here. Well, if the number of people who go to the movies increases, what should happen to the ticket sales? They should also increase. And we know that if we have a positive over a positive, that equals a positive. We could also look at this in the reverse way. If the number of people who go to the movies decreases, what's going to happen to the ticket sales? Well, the amount of ticket sales will decrease. So a negative over a negative is also going to be a positive. So no matter which way we looked at it, we got a positive relationship. Therefore, this has a positive correlation. And I would expect the graph, if I were to graph this, for the points to go up in a positive direction, but all scattered around. Number 8, the size of your TV and the time spent watching TV in a week. Well, I know from experience, it doesn't matter how big or small my TV is. It doesn't matter. I'll watch as much or as little TV as I want. So I believe this one has no correlation. And last but not least, the amount of water you drink, not your drink, and how thirsty you are. Well, if my amount of water increases, am I going to be more or less thirsty? I would be less thirsty. So a positive amount of water drank over the decrease in my thirst would have a negative relationship. And you could even think about this in the opposite way. If the amount of water you drink decreases, what will happen to your thirst? Well, should increase, because if you're not drinking water, you should be thirsty. Therefore, a negative over a positive is equal to a negative. So we say, since both of these came out to be a negative correlation, we're going to say it's negative. Before we get into doing some scatter plots, I wanted to do a recall. This is going to be needed to find the equation for the line of best fit, and it goes along with what we did earlier this year. So we're going to practice and review writing an equation of a line in slope-intercept form. And you may recall that slope-intercept form is y equals mx plus b. So to write an equation in slope-intercept form, we need to find the slope, and we need to find the y-intercept. Remember, the y-intercept is the point on the y-axis, 0, some number. So for our recall problem, let's do 7, 4, and 9, 8. So if I want to write an equation of a line, I need two pieces of information. I need the slope, so I need to find what that is. And I also need to find b, which we said was the y-intercept. So first, neither one of these is the y-intercept, because for it to be the y-intercept, the x-coordinate has to be 0. The x-coordinate's not 0, the x-coordinate not 0, neither one of these is the y-intercept. But I can find the slope using the slope formula. If you recall, the slope formula is y2 minus y1 over x2 minus x1. And I went ahead and labeled my points x1, y1, x2, y2. Remember, the 1's just mean they came from the first point, and the 2's just mean that they came from the second. I'm going to plug them in my formula, and this will help me find m. So m equals 8 minus 4, y2 minus y1, over x2 minus x1, and I get my slope to be 4 over 2, which reduces to 2. So I know my slope is 2, so I have half of my information. That was my step 1. Now for step 2, I need to find the y-intercept, and to do that, I'm going to use the slope of 2 and one of the points. And it doesn't matter which point you use. You'll get the same answer that I get even if you use a different point. I'm going to use the first point, but again, you could use the second. As long as your math is right and your signs are right, you'll get the same exact thing. And I'm going to plug them into the slope-intercept form. X plus b. Okay. So do I have y? I have a y right here. So I'm going to write down 4 equals m. M is 2. So I know that. Do I know what an x is? I do have an x. I have one right here. So that mx means m times x. So I'm going to times that by 7. And b I don't know, and that's what I'm trying to find. And now I have enough information to find that. Using inverse operations, I'm going to jump up here. I've lost some room here. I get negative 10 equals b. So I now have my y-intercept. And I can write my answer, which is the equation. It says to write an equation. I haven't written an equation yet. I found the parts of the equation, but I have not written the equation yet. So the answer is y equals, instead of writing m, we know it's 2. We write x. And it says plus b, but since b is negative, we say minus 10. And this is the equation of the line for these 2 points. Okay, now we're going to look at how to apply what we've just learned about scatter plots. And to do that, we're going to be using real world problems, or an example of a way it could be used. So a history teacher in this problem asked their students how many hours they slept the night before the test, and they recorded their data in this table. So to start with, we're going to record all of our data on this scatter plot here. Always, before you do this, make sure you've labeled your units for each of the axes. Since this is the x-axis, x always comes first in the table, y always comes second. Test scores. Also, if you look at the numbers here, we go from the lowest number looks like 4 and the highest is 9. So choose your scale, which is the distance between numbers, or your increments. It looks like they chose a scale of 1. That means there's a distance of 1 between each number, since these aren't that far apart from each other to begin with. On the y-axis, they have decided on an increment of 5. Every 5 they're going to increase, because the lowest is 60, the highest is 90. I don't want to do by 1s, that's a lot. I don't want to do by 2s. 10s are a little too much. 5s seem to be just right for what we need, and will give me a good picture that I can see clearly. Right here, you notice that that's not an increment of 5. It goes from 0 to 60. When you see a little zigzag like that, or some little thing from the origin up to the first number, that's called a break in the graph. It's kind of like zooming in on a picture. I don't want to see anything below 60 because my data doesn't have anything below 60. So I can squish that part of the axis down so I can only focus on what I need. So let's go ahead and start plotting these. Got 80 and 80, or 8 and 83. And these, just do the best you can. They might be a little off, but they'll be pretty darn close. 7 and 86, about right there. And 7 and 74. We've got 8 and 88, it's about right there. 6 and 76, just a little bit above the 75. 5 and 63, about there. 7, 90 is all the way up here. 4 and 60 is my low on the data. You probably already see a trend going here. 9, 89, it's almost a 90. And the last one I have here is 7 and 81. Okay, so there's my data. So the first thing you want to look at is, what kind of relationship do you see? Is it positive? Is it negative? Is it strong? Is it weak? Which one do you think it is? It definitely looks like it's trying to be a line, and it looks like it's slanting in the upward positive direction. It's very close. They're not too scattered out, so I'm going to say that this is a strong positive correlation. The second thing I want us to look at is drawing what we call a line of best fit, or a trend line. What that is, it's like the average of all these points. If these points were going to make a line, what line would they make? The best and easiest way to do this is to draw a circle around your data, and then draw a line straight down the middle of it. And that's your trend line, or line of best fit. Also, again, referred to as a trend line. This can help you make predictions as to what might happen in the future, or what might happen if you did less hours of sleep, where that might land you. So speaking of predictions, we're going to do that next. Now that I've got my line of best fit, we're going to use that to make predictions, just like we would if I had drawn a line and said predict what would happen in 5 years from now. Kind of the same idea. So let's make some predictions. The prediction I want us to make is what your test score would be for 10 hours of sleep. And there's two ways we can do this. One way is by the graph, and we just go over to the graph, find your 10 hours of sleep, since that's X, go up until you hit the line. I hit it right there, and now I'm going to go over until I hit the y-axis, and that should correlate. That's a rough estimate. It's a prediction as to what might happen. Well, since these are increments of 5, that would make this 95, and that makes this 100. So it looks like if I got 10 hours of sleep, my score is 100%, roughly. You might get 99, or you might have gotten higher. Again, it's going to be a ballpark estimate because we all are going to draw different lines. They're not going to be exactly right, but they'll be in the same range. Also, with the line of best fit, when you're drawing that line, again, it's straight down the middle of the circle you drew, which means it's like an average. So what you're looking for is about half the dots below and about half the dots above. If some of them hit them, that's even better. So use that to help you make your prediction on a graph. Again, I went to 10 hours of sleep. I went up until I hit the line, and then over to the y-axis to find the score of the test. I could have said, let's predict what would happen for me to make an 85 on the test. So I would start with the 85. I would go over till I hit the graph here, and I would come down. So again, 85 until I hit the line, come down, and it looks like about 7.5 hours to make an 85 according to this data. Now, the second way, I said there were 2 ways you could predict. One way is using the graph. The second way is to find the equation of the line of best fit. And that's why we did the recall a minute ago on how to find an equation of a line in slope-intercept form. So to do this, you need 2 points on this line. We have lots of data points, but not all of them hit the line, and some of them may not hit it at all. And it's okay to use points, like right here, it looks like it doesn't hit this red one, but it hits right below it at exactly 7 and 80, and you can use that. It does not have to be one of the points that you were given. So if your line goes through the corner of one of the grid squares, you can use that as long as it's within the circle. So I'm going to use that one, which is 7, 80. Again, it's not one of the data points I was given, but it is something my line hit. And if I look, it definitely hit right here. So I'm going to use the 4, using these 2 right there, 4 and 60. Those are the 2 points I'm going to use to find my equation. So if you remember from the recall, we needed to first find the slope. So we're going to do 80 minus 60 over 7 minus 4. This is equal to 20 over 3. And it's roughly going to be what? You can leave it like that for the most accurate answer, or you can use about 6.7. If you would like to round it, that is fine for these. The most accurate answer will be to use the fraction non-rounded, but you can use the 6.7. Okay? Now, we also need to find the slope, the y-intercept. So I'm going to use the slope. I'm going to use my first point. I'm going to plug it in. So y is 80, which equals to m, which is 6.7, times x, which is 7, plus b. And when I solve this, 6.7 times 7, remember this is all an estimate. It may not come out perfect to what we did with the graph, but it's going to be awful close. So 6.7 times 7 is 46.9. Subtract that from both sides. And I get 33.1 is equal to b. So my equation will be the slope plus the y-intercept. This equation is the equation of the line of best fit, or the equation for the trend line, and it can be also used to make predictions. Just like here, I used 10 hours was x. I can plug that in for x. That is 67. And so y, the test score they're saying should be, I'm just gonna make sure it's still early in the morning for me, 100.1%. And that's pretty close, if not exactly close to what I got when I estimated on the graph itself. So again, two ways you might be asked. If it doesn't ask you to write an equation, don't do it. But you can predict just by using the graph if you're given the graph. If you're not given the graph, I probably would use the equation unless it specifically asks you to. Okay, for our last problem, we're going to do the same thing we did with the other problem. This one is about 3 hours spent outside, and the person recorded the temperature and how much water they drank. We kind of looked at one like this, and we kind of have an idea about what this is going to entail. So we're going to create a scatter plot based off of this data and answer the same questions. It looks like we are comparing, they've already got it labeled for us, the water consumption, which is this one. Normally we said the second column is y, but they have told us it is x, so this is our x. And the temperature, which is our y. And I know that's backwards, but if they tell you different, that's what you go with. If we're doing it ourselves, creating our own graph, it's however you set it up. Again, you see this little thing down here? That's a break in the graph. So it goes from 0 to 70 and then 70 to 75. That means I just want to zoom in on a little section of the graph. They chose their increments. It looks like their highest one is a 99 and their lowest is a 75. So they wanted to get a little bit above and a little bit below. So they went by increments of 5. I guess you could start with 75, but sometimes it's a good idea to start a little bit lower just to get a better picture. In the water consumption, the lowest number is 16. Looks like the highest one is 48. So that's kind of a good range there. You could have done by 5s. They decided to go by 4s. That's fine. I would not have done anything bigger than 5s though. All right, so let's start by graphing all of this information. Be really careful you're not doing x to y, that you're doing x to y this way, because it's different than what we like to normally think. Okay, we got 27 and 85, about right there. 48 again, and 97. Just a little bit below. That's kind of a little cluster forming there. Let's see, 16 and 75. 32 and 92 is about right there. And then we've got 25, just a little past the 24, and 85. And the last one is 20 and 83. Okay, so we've got our data plotted. Now what do you think? Is it a positive correlation or a negative correlation or no correlation? Definitely is looking like a positive correlation. These look like they could be making a line slanted this direction. I'd say it's definitely a strong correlation as they're pretty close to a line. So I'm going to say that this is a strong positive correlation. Next thing we did, we practiced. I know the directions don't ask this, but if it did, it would ask you to find the trend line or to draw a trend line. So I'm going to circle my data, okay? Circle your data, and then if you draw a line through the center of it, that's your trend line, okay? This is your line of best fit, or also what we call a trend line. And it can help us make the predictions. Remember, when we're doing a line of best fit, we're trying to get about half above, half below. You may want to use a ruler to get you a little bit better line. Mine started getting a little curvy. It looks like it probably should have gone through this point, but started curving up. And again, it's fine if it doesn't go through a point, because you could use, you see where it hits the corner of that grid mark right there? You could use that as well. I could use this one right here. Even though they're not original data points, it's whatever your line hits is what you can use. So let's make a prediction. Let's predict the temperature. Actually, let's predict the water when the temp is 90 degrees. So remember, there are two ways to do this. If we were asked to do this and we were given the graph, probably the quickest way. So what is the water consumption when the temperature is 90? So go with your given information. I was given 90. Go over until you hit the line, and then go down to make your prediction. And it looks like it would be at about 33 or 34 ounces of water if the temperature is 90. Remember, we can also do this with a line of best fit, finding the equation of the line of best fit. So to do that, we need 2 points off of this line that I drew. I could use this one since it's one of my data points. So I'm going to, because my line definitely hit that point. And it looks like that one was the 2785. Just make sure you write them as X comma Y in this case, because this one is backwards. And since it didn't really hit any of the other blue dots but got close, I need to pick one, either this 2080 or this 48100. Either one is fine. Again, they weren't one of the ones from the table, and that's okay. I'm gonna go with the smaller one. So I'm gonna use the 20 and the 80. Just makes the math easier. All right, so now I have to find the slope first. So I'm gonna do 85 minus 80, y2 minus y1, over x2 minus x1. And I get 5 over, it looks like 7. So you can leave it like that, or for this time, it would be okay if you wanted to round it. This will give you the more accurate answer. And again, you can use a calculator. If you want to be super accurate, go out to 2 decimal points. They'll be a little bit more accurate there. Now let's find the y-intercept. So I'm going to use the first point and the slope. So y, which was 80, is equal to the slope times x. Y equals mx. Don't forget the plus b so you know what you're solving for. So let's figure out what 0.17 times 20 is. It's 14.2 equals 80. Move the 14.2 over using inverse operations. And we get that b is equal to 65.8. Therefore, my equation for the line of best fit, or trend line, however you want to say it, is the slope value. So y equals 0.17x plus the y-intercept. And now I can use that to make my prediction. My question I was predicting originally was what is the water when the temperature is 90? So the temperature was our y. So that means I'm going to plug in 90 for y. Instead of x this time, you plug it in for whatever variable you are given. And then we solve for x using our inverse operations we learned in 7th grade. Get 24.2 is equal to 0.17x. Divide by 0.17. and I got X is equal to 34 ounces. So my prediction using the line of best fit was 34 ounces. My prediction using the graph was 33, or you might have gotten 34, so we are pretty dead on. Remember, you could even be a couple away, and as long as you're within like a range of 2 or 3 on either side, you're okay. So to recap, plot your points, determine if it's a positive or a negative correlation. If you're asked to draw the line of best fit, circle the data first, and then draw a line through the middle of it as like your average line to all the points. And remember, you're looking for about half the data above, half the data below, maybe some of it falling on the line. All of that is okay. You can use that line now to make predictions as to what could happen based on the data you've collected. So we made a prediction one way using the graph. We went over to the line and down. We made a prediction the second way by finding the equation of the line of best fit and then plugging in the 90 for the temperature to find how many ounces that would be. And as we saw, they were almost identical.